Who's got an answer for me? Heyman, hit me. 729. Oh, you actually evaluated it. Right, okay. So Heyman has 729 over 64, which is, of course, 3 to the 6th over 4 to the 3rd. Go, Burke. Everybody knows why, right? The outside exponent. Oh, crap. I got to make that thing happen. 1 second. I'm with you. I need to make the little whatchamacallit, who's a what's it, the pen circle show up. The exponent that's outside, that's negative, flips the entire fraction over and then multiplies in. Right? I'll show you in a sec when I get my little pen light thing going. Except it's not going. This is what destroyed my computer yesterday. This thing. Whatever, it's not working. I'll fix it later. The 3, the negative 3 flips those over. Oh, wait. Oh, what the halibut? Whatever. Why is the dot over there? Piss off. The negative 3 flips it to 4 to the negative 1 over 3 to the negative 2, all cubed. Then, of course, you run that in. 4 to the negative 3 over 3 to the negative 6. Negative 3 has to go down. Negative 6 has to come up. Number 2, what you got? Pardon me? 16, absolutely correct. Does anybody need to see why? And if you don't have 16, you should be asking why. Excellent. So, in these brackets, I have 4 to the 3rd squared over 4 to the 4th. That multiplies 4 to the 6th over 4 to the 4th. 6 minus 4 is 4 squared. 4 squared is 16. Everybody good? Sweet. Who's got an answer for number 3 for me? 9. Does anybody need to see why it is 9? And again, if you don't have 9 written, you want to see why it is 9. Okay. Same thing. 5 plus negative 2, 3 cubed to the 4th over 3 squared to the 5th, which is 3 to the 12th over 3 to the 10th. 12 minus 10 is 3 squared. 3 squared is 9. Simplify and rewrite using only positive exponents. Who has an answer for me? X cubed. Does anybody need to see why? Yes? Okay. That is x to the 5 times negative 2 is negative 10. X to the negative 13th. Negative 10 minus negative 13 is positive 3. Negative 10 minus negative 13, 2 negatives, is a positive. Number 5. Who has an answer for 5 for me? It's a little bit trickier. Anybody want to try it? Damaris, hit me.
4y to the 6 x to the over x to the 4.
Nicely done. Well played, Damaris. Do I need to show it? I bet I do. So, negative 2 outside. I like to flip everything when that happens. Cubed over 4x to the negative 2. Sorry, x to the 2, not negative 2, dummy head. All that squared. Now, deal with inside the brackets first. the 2 is part of the base. So that is 8y cubed over 4x squared. Where? What's 2? What? Oh, thank you. It's cubed outside, or squared outside. Thank you. 8 divided by 4 is 2y cubed over x squared. All of that is squared. Since the 2 is part of the base, it is 4y to the 6th over x to the 4th. Gouda? Gouda. Now, over on 6, things change because there are now variables in the exponents in number 6. But just because it looks different, does that mean we change the rules? No, of course not. Since they are the same base and we're dividing, we subtract the exponents. So that is 12x minus 2x. So that is 18 to the 14x. 8. Did I say 18? 8 to the 14x. But I wrote 8. Weird. I must be getting old. Over on this one, remember this is really 20 over negative 5 and x to the negative 20 over x to the negative 5. Do that one first to get negative 4. Negative 20 minus 15 is x to the negative 15. What there is not allowed? The negative 15. Does that negative 15 have anything to do with the 4? No, it is not part of the base. So the answer is negative 4 over x to the 15th. Now some of you, even though I've said this a million times, are going to say, not allowed a negative in an exponent. You are. Bases can be negative. Exponents can't be negative. Oh, and this one, barf. What are you going to do with that? Anybody got an answer for me? If you only had that, what would you do with that 16 that's in front of that 2? You would distribute it in, right? Well, if there's a rule in math, do we follow it? Yeah, even if everything else looks different. So all you do is what you actually know. Leave the 16, leave the x, leave the 4, leave the x. Fix up the exponent. Negative 32n plus 48 over 4n minus 4. Now, what are you going to do with 16 and 4? Divide it, because that's what you do. 4. What are you going to do with these two exponents? Are they the same base? Is it division? So what are you going to do? Subtract. What's negative 32 minus 4? Negative 36n. And what's 48 minus 4? 52, right? Now, what do I got to do with that? What do I got to do with that? He waited patiently. Oh, I forgot there's a negative 4 there, so that's negative 4. What do I do with the base with the negative exponent? You got to move it. 36n. Now, what happens to that? Because when I make this positive, what do I multiply it by? Negative 1. So the 36 goes positive. What happens to the 52? It goes negative. And finally, some easier ones for 9 and 10 and 11. Well, 9 and 10. 9, there's two ways you can do it. Some of you will want to start in the brackets. And some of you will want to distribute that 2 into the middle. Right? Does it matter which way you do this? No. I recommend starting in here, because if you got to distribute that 2 in all over the place, there's a chance that you're going to make an error. So I like to make it as simple as possible and deal with the inside first. 6 divided by 2 is 3. X to the 3 divided by x is x squared. And that is now y to the negative 3. Now some of you will say, why am I putting that negative 3 there? Because the question's not done. It may fix itself. Now all of that is squared to get 9, x to the 4th, y to the negative 6th. It didn't fix itself, so we're going to move just the y at the end. And everybody should be pretty good with these. Now, number 10 always messes people up. What about it messes people up? That 4 out there, they remember that it goes to the A and the B, but they forget that it goes to the 2. Did any of you forget that it goes to the 2? Good. So that is 16 A to the 4th, B to the 8th, over 2 A to the 6th, B to the 3rd. Then, of course, you just deal with numbers and like terms. 4 minus 6 is negative 2. 8 minus 3 is 5. What there isn't allowed? The negative 2. So it's 8b to the 5th over a to the 2. And lastly, very tricky. What makes number 11 tricky? There's exponents with variables and 4, 8, and 16. Are you allowed to do exponent laws with 4, 8, and 16? Yes or no? No, why not, Heyman? They're not the same base, are they? Can you make them the same base? How? Multiply what? If you multiplied that, then you got to multiply everything by 4. Damaris.
Can't you change them to 2 and then raise them?
That's how you do it. 4 is really 2 squared, isn't it? Then 4 to the x times, what's 8 really? 2 cubed to the x plus 4 over 16 is 2 to the 4th to the x plus 1. Now what can you do over the brackets? Now what do you do? Same thing we did in all the rest of them. What do? Multiply 2 to the 2x times 2 to the 3x plus 12 over 2 to the 4x plus 1. Now, are they all the same base? So it's 2 to the 5x plus 12 over 2 to the 4x plus 1. Now what? Sorry, 4x plus 4. Now what? Even if you didn't do it by now, you should have figured it out. Subtract. What's 5 minus 4? 2 to the x. And what's 12 minus 4? 8. And you're done. Now, later in your math career, you will be taught how to deal with that. But for our purposes in grade 11, that's where we end. Okay? Well, that did not go as well as I would have hoped it would go. So you guys should do 1 to 12 right now, please. Does anybody want any of 1, 2, 3, 4, 5 explained? Pardon me? 1, yep. Numbers with numbers. 3 times 2 is 6. Y, negative 4 plus 3 is x to the negative 1. The negative 1 can't be there, so it's got to go down there, and we don't write 1 as an exponent. I'm going to try and get my little highlighter thing back because I really like that thing. Everybody's good with the rest of 1, 2, 3, 4, and 5? Number 5. Okay. So I, Rena, like to forget about the negative till the end because I know the whole thing is going to be negative. So I just work inside here. So I've got 2x, 4y, negative 3. Nothing else happening up top. And on the bottom, I have 12, 4 times 3, x to the 5th, y to the 5th. Right? Y to the 6th. Thank you. Now, 2 over 12 is 1/6. 4 minus 5 is x to the negative 1. So I'm going to move it down right now. And negative 3 minus 6 is negative 9. So I'm going to move the y down now. And the whole thing has to be negative because there's a negative out front. Okay? Remember, ladies and gentlemen, a negative out front of anything is this. There's a negative there, and just whatever's after it is negative. So you can treat this the way you would treat it normally, and then put the negative in at the end. I'll wait a few more minutes, then I'll do 6 through 10. Yeah, sure. No problem, Lucas. Ah! Sorry, Lucas. Oh, all right. I'm going to shrink this down a little bit so I can get more of it on the screen. Oh, page 5, number 9. Right there. Now, ladies and gentlemen, I would like to remind you once again that although there are only really 5 things you have to remember about exponents, right? You can see how easy it is to make an error, even though there's only 5 things you got to remember, right? This takes a great deal of attention to detail, right? The work isn't that hard. Add, subtract, multiply, divide, right? Negatives move up or down. Those are the 5 things you got to remember. But when you put them all together, it gets a little, right? So please work carefully. That's why we're doing so much practice with this, because if you have yet to figure it out, obviously there's going to be a whole lot of exponent work throughout the course of this course. Okay? That's why we're doing so much practice. That's why I want to make sure you're to the point where you can do it, not do it. Do you understand the difference? There's getting through it, and then there's doing the work. Everybody understands, right? Okay. Now, I forgot to record going over, I think, number 12. But all the work is there now, and it's recording, so it would be on YouTube if you wanted to watch it. Okay? I'm going to pause the recording, so I'm just going to be walking around helping.